This is the balanced chemical reaction of methane reacting with chlorine gas to produce dichloromethane and hydrochloric acid in a 1 liter vessel. This apple-looking pitcher here is meant to be a 1 liter vessel. And at equilibrium, all 4 species are present inside of this vessel here, although in different quantities. We are given the quantities of some of these. We have 1/2 mole of methane. We have 0.25 moles of chlorine. We have 1.5 moles of dichloromethane. And we don't know how much HCl is present in there. We are told that the equilibrium constant K equals 0.5. What we would like to know or calculate or deduce is what is the molarity or concentration of HCl at equilibrium. This problem, because we know 4 of the 5 variables, we can solve for capital K. We can write the capital K equilibrium expression, plug in the numbers we know, rearrange, and solve for the unknown or solve for X. The capital K expression is going to have products over reactants with the molarity, the square brackets, being of interest. CH2, Cl2, HCl. From the balanced chemical reaction, we have to square the molarity of HCl. Down here are our reactants, CH4, Cl2, and we're going to square the molarity of Cl2. We know the value of K. Let's plug in what we know here and find out what's unknown. Remember that square brackets is hieroglyphics for molarity. So kind of filling in what we know here. CH4, we have 0.5 moles inside of a 1 liter container. For Cl2, we have 0.25 moles inside of a 1 liter container. Don't forget that that is going to be squared. For CH2, for dichloromethane, we have 1.5 moles divided by the volume. And for HCl, well, that's what we're trying to find. And the squared comes down. We know the value for K, 0.5. I hope you can see here now that we know all of these terms except for one. And we can just do a little bit of math here. We have to plug this out. This is kind of easy to do because it's all divided by 1 liter. But keep in mind that square brackets mean molarity, so we have to divide by whatever volume it is. Divide, divide, divide. Multiply, don't forget to square, isolate for X, and do the square root as the final step to solve for the unknown molarity of HCl at equilibrium. Thank you.